And here, guys, we're going to go through it. I'll do my best to see if I understand it. If I do, I will try to explain it with my own words. And let's try to understand it together. If I don't understand it or I say something wrong, which there are high chances, I'm just learning here, never read this before. So yeah, let's help me please at any point. I'm actually considering if this series, if this video is getting, if it's popular or liked by you guys, then eventually we could do a live session here and listen live for suggestions or help from you guys. Because actually, I'm even considering having guests to help me or to study with me, basically, more than to help me, which obviously yes, but it will be interesting to have guests with whom we can study and the guests from which we can learn from, especially me. But yeah, let's see. Let's go back. There was one high only. Seems so, yes. One high for mediums and a ton of low and a ton of gas optimizations. Okay, let's start here. Transferring KIB token to yourself increases your balance. So that's probably a lack of verification of the addresses. That's interesting. Using temporary variables to update balances is a dangerous construction. Temporary variables, I need to see what it's referring to. If transferred to yourself, it will cause your balance to increase. KIB token overrides transfer. See, that's a problem of KIB. It is probably from KUMA. KIB token, that's a problem of overriding the functions from the Open Zeppelin. It's checking the address to, but it's only checking that it's not 0. And there's no other check about the addresses. And apparently, to perform the transfer of the token, the code is as follows. This is a proof of concept. So I understand it's going to show. So I think this is just the same proof of concept is where you are trying to crack it, but I think for now it's just showing where it's crackable. Base balances 2, okay. New to base. Let's go here and analyze. New to base is defined here. Okay, this is the balance. New to base balance. Okay, there is some operations here, and then it's assigned the base balances. It's changing the balances of the address that is receiving it, or similar. Let's read it more. But I understand that you can update your own. You can send it from yours and send it to yourself actually. I think I've seen it some places. To have the if from needs to be different than to. Okay. Okay, so it's pointing here if what I say, right? If it's equal, this place will override the reduction above. Yeah, that's very well seen. From the code above, we can see that using temporary variables. Okay, that's what it's calling temporary variables is. Okay, so local variables, basically. Those variables disappear when the function when it's finished, the logic inside the function. If the from and to are the same, the balance to update will override the balance from update. To simplify example, balance Alice 10 and execute transfer from Alice to Alice and 5. Define the temporary variable Alice 10. So update the steps as follows. This makes it 5 and from. I'm not sure I understood that. But this is first the from and then the to. And let's see. Okay, this is what it means probably. After Alice transferred it to herself, the balance was increased by 5. Okay. The test code is as follows. Test transfer same. Mint code is okay. We're minting from Alice. That's a random address there, 10 ethers. We're checking that Alice's balance is 10 ethers, and we're transferring 5 ethers to Alice. And it increases by 5 with the transfer. Because it's here increasing it. Okay, I get it. Okay, nice. Here it's showing how to run it with Foundry. In general, we could add to. Oh, look. Why not? Let's do it. We can add it to KIB token transfer T. Tests. KIB token. Oh my god. Transfer. KIB token transfer T. Okay, we got it. So I can add it at the end here and run as they say like that. Oh, remember I said there was something, a surprise at the beginning of the video, that there were 3 failing tests. Let's run this. Hopefully it works and we can see the results. And then we go through the mitigation. Let's see. Maybe let's not wait much, but don't know if this will work. Let's see recommended mitigation steps. A more general method is to use balance to balance from. Okay, so yeah, running. But I would add okay, that's interesting, but I think you can solve this by adding a condition. But yeah, I guess here it is. Yeah, makes sense. That's good. And this is the comments probably, or the judge. Okay, and then they fixed it probably here. Let's check. This is the pull request. We can see their changes. There you go, that's how they solved it. Just with the... that's what I thought. That's what I was speaking about. Nice. Cannot transfer to self. And the other test case. Cool. Okay, then let's go to medium risk findings. There are a few here, so let's see. KUMA bond token approved. Should revert if the owner of the token ID is blacklisted. Oh, it's not handled that. Okay. It is still possible for a blacklisted user bond user bond's token to be approved. Okay. Only this approve only checks if message sender and 2 are not blacklisted. It doesn't check if the owner of the token ID is not blacklisted. Interesting. Okay, let's take a look at that KUMA bond token. KUMA. Let's close this. KUMA bond token. Approve one. Yeah, because it's the not blacklisted 2 and not blacklisted message sender. But the token owner. Oh look. Owner of this. Oh, that's true. Okay, let's see what else it says. For example, the following scenario allows a blacklisted user's bond token to be approved. User A have a bond token BT1. User A calls set approval for all be true, and user B can operate on all user A bond tokens. User A is blacklisted. User B calls to approve user C to operate on bond token. Let's see the mitigation in this case. Yeah, probably adding the that's probably you can define. Okay, no, but yeah, adding the basically another line here with this code. So with the owner, basically the address of the owner. Nice. Okay, let's go on. Again, it's nice to see they are adding the test as the proof of concept to prove it. I wonder if it ran the previous one. It did. Not as much. Oh, what? Didn't match the test? Why? Test transfer same. And what did they run? I don't know. Seems the same. Okay, never mind. But this should work. Probably there's some weird thing I'm missing there. But that's okay. Let's go on with the issues. KUMA fee collector change payees. KUMA fee collector executes incorrectly when new payees contains duplicate items. The payees are the everyone that is involved, and they are were the ones to whom the fees are redirected later. Executes incorrectly when new payees contains duplicate items. Let's see. When calling KUMA fee collector, change payees with duplicate payees, new payees, the call is not reverted and the result state will be incorrect. Okay. Proof of concept. This contract does not support duplicate payees. The transaction will revert when trying to add duplicate payees. Okay. I see. But add payees this, but function forgets this constraint, which allows duplicate payees to be passed. It's missing the verification. Yeah, that's true. This will cause the contract to record an incorrect state and not work properly. Nice, I guess desktop POC, I guess the solution is to add it, add that verification. This is the test. The mitigation should revert if there are duplicates, so should be adding that condition, yes. In the change fee, do you see it somewhere? I see only contract. Okay, it's not showing the whole code, I guess, but yeah, basically it's adding that condition when we are changing the payee. We can check it on the PR for mitigation. There you go, yeah. Let's see, let's double check that it's in the change fee payees. It is, yes. Okay, good. Let's go on. Price feed in get rate is not sufficiently validated and can return stale price. Okay, let's see how it's not sufficiently validated. I think we didn't check this contract anyways. Or we did. Don't remember. Okay, but see, this is something I mentioned. There's a possibility that the data from Oracle it's not there's an error basically. So it's always important to make sure. So it's always a kind of flag when not a flag as something bad, but an attention to oracles always and getting the rate from them. So get rate only uses answer but never checks the freshness of the data. Okay. Which can lead to stale bond pricing data. Stale pricing data can lead to bonds being bought and sold on KUMA swap that otherwise should not be available. This would harm KAB token holders, as KUMA swap may accept bond with too low of a coupon and reduce rewards. Okay. So needs to have a validation of the current data. So let's see. Recommend the mitigations, validate that updated at. Answer latest. So instead of having this, you see the plus line, you need to also take the time probably it's updated at and check that it's up to date, I guess. Yeah, this is the way of showing it. And if so, reverts if it's not up to date. The warning has shown how the system will not check for a stale price. Yeah, stale is like no longer fresh. Okay, so outdated basically. This issue is tricky. Okay, it is. Central bank rate updates are not expected more than a handful of times a year. So that's probably why it's not a high, I guess. I see there was some negotiation there, but yeah. Let's go to the next. KUMA swap incorrectly reversed when max coupons has been reached. Let's look at that. Okay. If the coupon's length is max coupons revert, the above lines will cause all bond sales to revert. Okay, and we don't want that since bonds may share the same coupon. The swap should continue to accept bonds with a coupon that already exists. Okay. One thing are bonds and the other coupons. That's why that, okay. Mitigation step. So this is, okay. Sell bond should only revert if the max length has been reached and bond coupon doesn't already exist. So we need to add another condition there. So we have the coupon's length, that verification that we had, and we need to make sure that also coupon doesn't contain. Because if it contains, this end will break and it will not revert. Okay, got it. See, a lot of verifications there are super important. Okay. Even though this scenario is unlikely to ever happen, we have confirmed this issue in a test. Okay, that's probably the limit. Okay, and the discussion and the mitigation. Let's see how they mitigated it. Files changed. Those are usually very quick. Well, at least in this probably very quick fixes. Quick, short at least. lack of verifications, right? Yeah. Okay. And some low risks. Let's go through them. For this contest, 4 reports were submitted, blah, 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 blah. KBC, I think this, yeah, I've seen this before. It is for each contract, it is showing a list, right? Like 01 here, but then it changes the letters there, and it says how many issues in each contract. Interesting way of showing as well. Let's go a bit through those. Improper disable of initializer. Oh, I think I've mentioned that earlier. It uses dependency with initializer contract being okay. This allow then. Okay, interesting. Good to know. The contract contains a dedicated disable initializer function meant to be invoked by contract construction implementations in contracts that inherit, ensuring that the contract cannot be initialized or reinitialized in the future. In current implementation, the initializer modifier is simply added to the contract's constructor, which does not disable the initializer properly, as it still permits the reinitialization to occur. Yeah, okay. I think I did mark that as a thing to check, right? Okay. Improper disable of initializer. Okay, it's happening in a few contracts, so it's probably going to repeat it. A different way of raising this is raising the issue as low and adding the different places where this is happening instead of duplicating it. But yeah, I guess it's also possible to do it this way. Insufficient initial epoch sanitization. Set epoch length function properly evaluates that epoch length provided is not greater than. No such sanitization is applied during the initialize function. We advise the initialize function to apply to same logical checks, potential refactor to an internal function that both code segments utilize. Yeah, using those upgradable initialize always brings more attention, needs more attention, definitely. I'm not sure about this, honestly, so I will go on. Discrepant epoch inclusivity definitions. Probably there is some different from the documentation. Usually, when you go through the documentations, you need to make sure if it applies on the contracts. So most likely, this kind of laws is how it's called. So it's basically not following the documentation. But let's see. We advise either the assignment initialized to add epoch length in existing environment of minimum maximums in yield. The max yield constant variable declared remains unutilized. We advise it to be enforced in the refresh yield function by ensuring that the lowest yield being set is at most equal to max yield, in which case the value of max yield should be used instead. Additional domain, okay. Initializer, improper release event. Let's see what happens with the event. May operate in an empty data entry. In such case, if funds to be distributed are present in the contract, this function will incorrectly execute release, which in turn will emit fee released event for the available income. We advise the function to be invoked solely when, okay, is non-zero in the reference instance, as otherwise incorrect events may be emitted and be misleading probably. In existing duplicate entry prevention, I think this is similar to what we've seen earlier. We advise the code to add a new if condition which causes the code to fail if it contains that payee already. In existing limitation of variable fee, function does not apply any sanitation on the variable fee value, permitting a fee to be applied that exceeds the 100% value of the bond. We advise the variable fee input variable of set fees to be validated as less than, and preferably less than, a stricter value, to ensure unfair fees are not applied in the protocol. Again, this is following some of the documentation. This finding also ties in with the slippage-related vulnerability submitting a separate exhibit whereby a user could submit a transaction with a blockchain state that applies a 5% fee, and the fee could change between the transaction submission. How many more? Okay. KUMA swap. In the existing limitation of variable fee does not apply a citation. It's always usually missing checks. Permitting a fee to be applied that exceeds the 100% value of the bond. We advise variable fee input variable offset fees to be validated as less than percentage factor and preferably less than a stricter value, 20%, to ensure unfair fees are not applied. Slippage-related vulnerability. Inexistent limitation of bond. There are lots of those. Improper disable of an... Okay, we've seen that. Unsafe casting. Cast the result of that to a UN16 variable. We advise the casting operation to be performed safely by ensuring that the calculation result does not exceed maximum value data uint variable UN16. The built-in safe arithmetic strategy does not protect against casting overflows. I think it's called silent overflow. That's true. And it's allowed, okay. In existing citation of state transitions does not ensure that the previous state was the opposite of what it is being set to. We advise to be applied to prevent misuse of the function as well as misleading events. Weak definition of owner. This means function accepts a KYC data argument that is meant to contain data, a KYC person, permitting KYC data to be minted to an arbitrary address when the owner of the KYC data may be someone else. We advise the main function to permit minting of the KYC data by either reinforcing 2 to equal the data's owner member, okay, or by not accepting a 2 argument altogether. Potential approval backlist bypass with the approve. The function will apply a blacklist check on the 2 as well as message sender contextual arguments of the call. However, the actual owner of the token ID is not validated in contrast to set approval for all, which disallows an approval to be made by a party that is in the blacklist. While the approval cannot be actuated on by the transfer from, safe transfer from functions, as they do validate the from argument, an approval being made on behalf of a blacklisted owner is an undesired trait, similar to something we've seen before. We advise the code to properly apply the blacklist to the owner of the, yeah, we've seen that. Another inexistent sanitation of maximum answer. This is the library. Incorrect code merge. Ooh. The implementation not present on the ABV3 code base. And it's merged from, okay, that's an interesting catch. We advise the repo functions body to be wrapped in an unchecked code block, replicating the original behavior of Web3 ABE. We would like to note that while presently not a vulnerability, code copied from other projects should execute in the same format it originates from. Touche. Okay, those are the gas optimizations, but we're not gonna go through those, that's for sure. So this is mainly it. Mitigation review. It's probably, yeah, we already went through those. So guys, I think from now, as an experiment, this is all for now. So it's definitely been useful because I had to focus, like useful for me. I had to focus on what I was reading, what I was saying. Obviously, we didn't go deep, but it's a study session altogether. And yeah, let's see if you guys like it. Please let me know anything you didn't like, understand, or what other ways we could do this together. I think it is a way that you can see for those that are less experienced with the auditing, some basic ways of auditing, or at least to overview the project. And for those that you watch and you are more expert than me, I'd be happy to connect with you guys and either do a real audit together, or I would even love more if we could do another of these study sessions together so that more people can benefit from them actually. And yeah, let's stay in touch. Please let me know what you think of these sessions, and well, stay tuned for more since I'm starting with the channel, then I plan to try to push a different type of videos, different type of resources here. I have my articles on Medium. I have my account on Twitter. I am active in both. I will leave some links below. And yeah, guys, thanks a lot for staying by. Of course, please subscribe. This is only the beginning. And yeah, take care. Bye, guys.